Hello, my name is James Kress, and I'm from the KAUST Visualization Core Lab. Today, I'm going to be giving an introduction to scientific visualization with VisIt here at KAUST. So to start off with, I'm going to list a few different resources that we have available for our users here at KAUST. So if you need to contact me about HPC visualization, scientific visualization, you can use my email there and contact me. You can check us out on our KVL website, or you can send us some general inquiries for help with other things that the Visualization Lab can take care of at help@vis.kaust.edu.sa. And there are a number of different user resources for exploring different features and asking questions about VisIt. You can check out the VisIt website, the discussion forum, their user guide, and their wiki. So to start off with, I'd like to give a quick introduction to the Visualization Core Lab for those of you who may not know who we are and what our facilities are and what we can offer. So currently we're a 5-member team. The first 3 of us here, we have our lead. He is an expert in information visualization. And then we have our VR and AR expert. I focus on HPC scientific visualization as well as in-situ visualization. We have an expert in scientific visualization and an expert in data science. And so you can see we're a broadly based team, so we can help you out with a lot of different questions and inquiries. In order to access our facilities, you can book us on our control page, and that's available through our wiki as well. A few of our facilities require keycard access, so if you haven't booked us before, check that out early before you need to get in. And let's see, finally, what can we do for you as students and professors and everybody else here at KAUST? So we have 3 different kinds of requests that we generally receive. We have our standard requests where we're asked to load data X into program P and produce visualization P. And so that's kind of a basic request that we can help you figure out what program might be useful, show you how to load it, and teach you how to do those visualizations. And then you can get those done and do your publications and whatever else you need to do with those images. Next, we offer some advanced support. So if you want to ask questions, do some investigative visualization, we can help you figure out a pipeline to do that. And finally, we have our collaborations. And so these are more longer-term advanced workflows to where we help you through your entire research and discovery cycle. So if you have an interest in HPC, Viz, or in-situ visualization, let me know. I'd be happy to help. So the goals of today's workshop, we're going to be doing some hands-on learning with VisIt. So this is an introductory course. I'm not going to assume that you have any prior knowledge of VisIt. So we're going to do this hands-on learning through slides, and then at the end, we'll go through a number of different demonstrations. Why would you care to use VisIt here at KAUST? Well, there's a few different reasons. It's an open source, scalable, multi-platform visualization application with users worldwide. And it's available on all of our major computational resources here at KAUST. We have VisIt on both ibex and Shaheen, which allows support for distributed computations to process very large data sets. And VisIt has been proven in the past on over 27 billion element meshes, so very large data. We also have VisIt on our IT remote workstations, so you can access those anytime you need. And finally, we have VisIt at KVL, so we can use VisIt on our tiled display walls, and you can explore your data in extra large format. All right, so next, let's go over some VisIt basics and get you oriented to VisIt. So first off, what is VisIt? So VisIt is an open source turnkey application for data analysis and visualization of mesh-based data. It has an infrastructure for parallel post-processing that scales from laptops to HPC clusters, and it has built-in in-situ capabilities. So it's a very powerful tool and has a lot of different options and visualizations that you can do. So next, how do we spell VisIt? So this is an interesting slide. So VisIt was it was initially intended to mean visit as in go to or see. So to go to your data and see it, and as an abbreviation for visualize it or VisIt. But this is a terrible name if you're trying to use this to do online searches or find any information when you have issues. So as you can see on the left, if you Google VisIt from KAUST, you're going to get a number of different places you can go and visit, nothing about VisIt itself. So if you're having issues, make sure to use the mailing list archives and GitHub when you're searching for answers. So VisIt supports a wide range of different use cases. You can do data exploration, comparative analysis, quantitative analysis, visual debugging, and even presentation graphics. And you can do that through a wide range of different plotting types. So we have streamlines and pathlines, vectors, pseudo-color renderings, volume rendering, molecular visualization, and parallel coordinates. And that's just a few. So how do you obtain VisIt? So you can use an existing build. That's going to be your easiest bet here at KAUST. For your laptop or workstation, just simply download the binaries from the VisIt website. The KVL team, we manage builds on ibex and Shaheen, so we have that ready to go on both of those platforms. And you can access it on the IT remote workstations. And the last option is you can build VisIt yourself. And this is something you can do if you really need to enable a feature in VisIt that wasn't enabled on a prior build. How do you get your data into VisIt? So VisIt supports more than 110 different file formats, many different ways to get your data into VisIt. A few of the basic ones are VTK format, Silo, XDMF, PVTK, and then plain text. So you can import CSV files into VisIt as well. Finally, there's a VisIt writer utility code that you can use to write out VTK files from your simulation code. So if you have access to your source and you can input that, you can easily write out data that VisIt can read. And it has support for mesh-based data and conduit blueprint. And finally, if none of the above work, you can do a conversion through another program or even write your own reader. VisIt supports plugins, so you can write a reader that will let you get your data right into VisIt and get on with your visualization. So next, let's go over some core concepts in VisIt, and this will get you oriented into how it works the way it does and a little bit of why it works the way it does. So VisIt's infrastructure provides a flexible platform for custom workflows. It has a C++ plugin architecture with, like I just said a second ago, custom file formats, plots, operators, and you can create an interface for custom GUIs in Python, C++, and Java. It has a Python interface, and so this is very valuable for doing Python scripting and batch processing, as well as data analysis via Python expressions and queries. So there's a lot of power there. And finally, it has in-situ coupling. So VisIt has a library called libsim, which allows simulation codes to link directly to VisIt's engine for in-situ visualization. Next, let's talk a little bit about how VisIt uses data and how it accesses data. So VisIt uses MPI for distributed memory parallelism. And so what this means is you can see here we have our full data set rendered on the left. And on the right, we have this fancy cube with tons of different colors. And so what that's showing you are the different subgrids. And in this case, what a subgrid means is it's a block of data. And those blocks are loaded on different processes on a parallel machine. So if you're on ibex, for instance, you can load this data set, run it across 10 different nodes, have, say, 300 different processes, and then each of those processes is going to load one or more of these blocks and do the visualization work on it. And so that's the way that you can load and visualize data that your laptop or desktop could never handle by itself. And furthermore, we're currently in the process of enhancing VisIt's pipeline infrastructure to support threaded processing in many core architectures. So under the covers, VisIt uses something called VTK, if you've heard of VTK, the visualization toolkit. And currently, we're implementing different algorithms in VisIt using VTK-M, which is the many-core version of VTK, which allows us to take advantage of modern node architectures and really use all of those cores and GPUs. So things with VisIt will only get faster in the future. VisIt uses scalable rendering for large data. And so this is another important aspect about VisIt. So if you're not able to visualize the data on your laptop, you can do that on a parallel cluster. And on the parallel cluster, what it's going to do is each of those different tasks is going to render one piece of the data. In this case, we have 4 different tasks rendering 4 pieces. And then that image is going to be parallel composited, and then the image will be sent back to your laptop or your desktop for you to view. And so you're not actually having to send all of the data back from ibex or Shaheen, and you can just view that data right on your laptop. And in addition to the scalable surface rendering that you're seeing right here, VisIt also provides scalable volume rendering. And the final important piece about VisIt is that it employs a client-server architecture. And so you've heard me say the word VisIt engine a few times already. And so what that is on the server side, or the cluster side in this case, VisIt runs something called an engine, and that's where it does all of its work. That's what loads the data, that's what has the different visualization operations, and that those engines communicate via MPI and get all of the work done. On the client side, you have your viewer, so that's your GUI generally. And then the work's all being done on the parallel cluster, and then the images are just being sent back to you on your client. And so that's how VisIt lets you visualize very large data across the network. So VisIt's interface is based on 5 abstractions. And so this is important when we start to create pipelines in VisIt. So there's 5 different abstractions that can be used to create pipelines. You have databases, which read data. You have plots, which render data. You have operators, which manipulate data. Expressions, which generate derived quantities. And queries, which summarize data. So as an example of what some of this means, here's an example of a VisIt pipeline. This is the most simple pipeline you can probably do in VisIt. First, you open a database and then create a plot. So in this case, we're opening an HDF5 file, reading the data, and we're creating a pseudo-color plot of density. So that's using 2 of the 5 different abstractions to create a pipeline. This next example uses all 5 abstractions. So here we open a database, the same HDF5 file. We then create a new expression. And so an expression is a derived quantity. So in our data set, we have the value velocity, but we don't have the value speed. So we can create the value speed by taking the magnitude of velocity. So that's our expression. We then apply an operator. So that operator is the slice operator. So we're going to take a slice out of the data, a 2D slice. And then we're going to apply a second operator to transform the data. So let's say we're going to do an elevate. And so the elevate raises the data up from its current position. Next, we'll create a plot of pseudo-color. And finally, after we create that plot, let's say that we want to know what the maximum speed is across those slices, so we can do a query on the maximum speed. So that's an example of doing a number of different operations with the VisIt pipeline. And we'll see a bunch more examples as we get into our interactive session later on. And so next, let's do a VisIt interface tour and get ourselves oriented to VisIt and what it looks like, what the buttons are, and a little bit about how it works when you load it up. So when you start VisIt, you'll see something like this, except there will not be a plot showing. So you'll see 2 different windows. You'll see a plot window and your pipeline browser window. And so the plot window is over here on the right. It has all of these different buttons and controls, and that's where your plot is. And on the left, we have our pipeline browser, which has our pull-down menus where we can access a bunch of different options and controls. We have our active window selector, and that's important when you start having multiple plots that you're creating at the same time. Our data sources, this is how you open and load. This is how you open data, and you can view all of your different active sources through this drop down here. This is our time slider. So if you have time varying data, you can scroll through time and play through time with these buttons. We have our plots and operators buttons. And so the add is where you get to plots, and those are the main things that visualize data with VisIt. And then operators modify plots. And then below that is our pipeline browser, and that shows you how your plots and operators are composed. Another important one that I'll touch on later a few times is the apply to. So this can start to trip you up if you're not careful. So when you're applying different operators, if you have the apply operators to all plots checked, you may be applying operators to plots that you don't intend to. So we need to be careful, and I'll show you this in a little bit. The next area is something they call the notepad. And in this case, I have docked the engine information into my notepad, but the notepad is just a place where you can store different tabs and view different information in VisIt. And finally, we have your output indicator here at the bottom. And so if there's an error or a problem, this will turn red and probably you'll get a pop-up, but that's where you can view different output from VisIt. Okay, so now I'm going to do about a 5 or so minute VisIt GUI tour. And so on this tour, we will see how to open files, look at some of the different file types. We'll learn how to view the file info once we load a file. We'll learn how to navigate different views. We'll learn how to see and link multiple views. I'll show you some of the window tools in the view, show the add plot and add operator controls, the change plot and operator attributes, how you can change those. We'll show you how to selectively apply operators, and that's with the apply to, and finally linking views. So why don't we jump into that right now? Okay, so as VisIt starts, this is what you'll see. You'll see the main window as well as your pipeline browser, so 2 separate windows here. And you'll see your main window is completely blank, the pipeline's blank, and nothing's been loaded. So to start off with, let's just go ahead and open up a data set. So to do that, go over to your Sources tab, click Open, and you'll get your file open browser. And there's a little bit of information here that's useful to understand. You have something called your host, and what that is that's telling you what computer you're opening the file on. In this case, it's localhost. And later on, we'll talk about connecting to ibex, and so then ibex will be your host. Your path to where you're going to open up the data files. So you have your previous paths that you've used stored there. Something called a filter, which is great if you're opening a folder that has a ton of different files in it and you just want to open up the silo files, for instance. You can just put .silo, hit enter, and it will filter out everything except the .silo files. So it's very useful to help sort through files. And finally, you have something called the file grouping, which is useful if you're opening up data that is multi-block or time varying. So if that's set to smart, for instance, these PNGs will actually be a database, but I'll turn it off now. So then you could open them up individually in this case. And then over here, this is your directories. So you can go up and down through your directory structure, open up a directory, and then your files are listed on the right. So today we're just going to open up noise.silo. And before I click OK, one last thing is you have this open file type as. And so this is very important. Most of the time, or a lot of the time, VisIt can choose the correct reader for you. But in case it can't, and you know exactly which one you need to use, you can come in here and select that. And that's especially important if you're going to try to open a CSV file. You have to come in, select plain text, which is the CSV reader, and then you can set your default options. So set your X, Y, and Z coordinates and get your data loaded. But for now, I'm going to move it back up to guess from file name extension and open up noise.silo. So you'll see the file has opened, and we know that because it shows up here as our active source. No renderings or anything are going to be done yet, and that's done on purpose because when you load a file in VisIt, it's done under the assumption that this file could be very large and that doing an operation could be very expensive in terms of either computation or time. And so it doesn't want to do anything until you tell it to. So we know that our source is active. And let's say that this is the first time you've seen this file. You want to know that it loaded correctly, and you want to see what the different variables are that you have available. So to do that, go to File, and then click on File Information, and it will open up the File Information window. Here you'll see what database you've just opened. You'll see what the file format is, and that'll tell you what reader VisIt's using. And then underneath that, you'll see if it's time varying. And so in this case, there's only one time state. And then finally, you'll see your meshes. And so in this case, we have a 3D mesh called mesh. And we know it's 3 because its spatial dimensions equals 3. The extensor from 10 to -10. We also have one in a mesh that's 2D and a point mesh. And then underneath the meshes, we have our scalar variables. And so these are all the different variables we can plot on the 3D and 2D meshes. And then even further down, we've got vectors. So there are some vectors declared in this file as well. And so we can learn a lot of information about our file just by looking at file information. Okay, and so now that we know a little bit about our file, let's go ahead and create a very basic plot, and we'll start to learn how to navigate around. So to add a plot, you go to the plots area, you click add, and then you'll see all the different plot types that you can do. You can do boundary plots, contour plots, mesh plots, scatter plots, spreadsheets, vectors, volume rendering, and more. So to start off with, though, what I usually like to do is do a pseudocolor plot as my first operation, just to see what the data kind of starts to look like. And so in this case, a pseudocolor plot, all it does is it maps a color to the range of values in your data set and then renders that. So we'll do a pseudocolor of hardy global in this case. Then I'll click this button and then that will open up our pipeline tree. And so in this case, the pipeline is very simple. We're just doing a pseudocolor of the variable hardy global. So there's not much to see there yet. And so now that I'm happy with what we're going to do, we're going to click draw, and our pseudocolor plot will immediately draw. And so then we can go over to our window, our viewer window, and we can start to see what our plot looks like. So to navigate with the plot, it's very easy. If you have the navigation mode set to click and drag right here, all you have to do is click on the plot and with your mouse and drag it around, and you can start seeing what it looks like in 3D. To zoom in, you can use your middle mouse button, zoom in on the data and take a look at it, and then zoom out, of course. And let's say that you get into a state that you don't like and you want to get back to the original. You can reset your window by going up to these window controls here with the one that looks like two green arrows wrapped around a camera, and it's the reset view. So that'll reset your view, and that'll take you back to the original view. The next thing that you can do is there's a zoom mode up here. And so that's nice if you don't want to just scroll in, or if you have data that you want to zoom in really close on really easily. So you click the magnifying glass and then click and drag, and you'll get a zoom window, and you'll zoom right in on where your data is. Then next, I'm going to reset my view. Something I like to do is clean up this view a little bit. So right now it's kind of cluttered. And so I often like to turn on the black background. And so you can do that by swapping background colors. There's the button up here for that. Another thing you can do, just if you're interested, is toggle spin mode. I usually never use this, but if you want to have the plot continuously move after you let go of it, you can do that. And so I will drag the plot and throw it here. Oops. And then it will just continue to spin. And so that's what spin mode is. It'll just let the plots continuously spin around. But I'm going to turn that off because I don't really like that mode too often. And we'll go back to the original view. So what I want to do next really quickly is go to controls, annotation, and this will let me further continue to clean up the plot window. And so there's something called a legend. I usually leave that on because then you know what the values are associated with your plot. I don't usually care about the database or the user information. And so that'll turn off two things in your viewer window. And since we're in 3D, I'll go to 3D annotation. And I'm going to turn off show bounding box, and that'll make the plot a little bit cleaner around the data up there. And that should probably be good for now. So see, things are just a little bit cleaner. We've got less annotation on the screen, so things are easier to see. So now that that's done, I want to show you how to apply an operator. And so to apply an operator, you select the plot you want to apply it to. In this case, it's the pseudocolor plot. And let's say I want to do an isosurface. So I will click operators in this case. I will go down to slicing. So this is a type of slice, and I will select isosurface. And so you can see your plot disappeared again. And so this could be a heavy operation. So VisIt's not going to do it until you've got your settings done. So to access your settings, you can either right click on the operator, or it's easier just usually to double click it. and then the isosurface operator attributes will show up. And this is how you set what your isosurface is going to do. You can say, I want 10 different levels spread evenly between the min and max value. You can set individual values yourself, set percentages, you can set minimum and maximums, change it to log scale, etc. So I'm generally pretty happy with that, but we'll just reduce it, say, to 8 different levels. We'll click apply and dismiss. And then I want to change my pseudo-color plot attributes too. So I'll double click on the word pseudo-color, and that'll open up my pseudo-color plot attributes. I want to change the color table. I want to change it to hot desaturated. That's a color table that I like a lot. And so I'll click apply to there. And then that should be all we need from our plot attributes right now. So then we can go ahead and click draw, and our isosurface will show up. And so you can see we have 8 different isosurfaces maybe in there. And we can start to see inside of our data and see what the value ranges are and how things are formed. All right, and so the next thing I want to show is multiple views. So you can start to have multiple views and see a number of different bits of information at the same time. One easy way to do that is you can go up to your window controls again, and you can click 1x2 window layout, and that will open up a second window here. And now I have window 1 and window 2. And so this is where the active window becomes important. So I will change my active window to window 2. And so you can see my plot pipeline tree has gone away because there's nothing in window 2 yet. So now we'll go ahead and add something to window 2. In this case, I'd say let's go ahead and do a volume rendering. So we'll do a volume rendering of, say, Shepherd Global in this case. We'll just leave everything as default and click OK. And then our volume rendering generates. So we can play around with transfer functions and stuff to make that look nicer, but we'll work on that later. And so that's how you can do 2 different windows. If you want your window to be the same, something you can do is what I'll do right now. I'm going to close that window, and I'm actually going to go over here and click on clone. And so that'll clone window 1 and keep all of my settings in window 2. So I get my background and all of my annotations set the way I like them. And in this case, since I did a clone, it's also going to have the isosurface there. So we can just immediately render that, but that's not what we want. So I'll delete it. I'll go back to add volume rendering, go down to Shepherd Global as my variable, and click draw. So now we've got the same background and it looks a little bit cleaner. One thing that you may want to do while you're viewing your data is lock them together. And so that's interesting if you want to look at the same area of your data in 2 different or more windows. So you can go to lock view and do that in both windows. In this case, I'm right clicking. I go into lock view. You can also go up to your toolbar here and click on the lock button, and this will be lock view. We can also lock across time. So then when the view is locked, what that means is I can just interact with one window and it will show me the same view in the second window. So see, it rotated to the exact same angle in the second window. And if I zoom, let's say I want to zoom in on this area here, we can zoom in on the same spot in both at the same time. So that's kind of useful when you're having multiple plots open and want to scroll through them. So what I'm going to do now is go ahead and reset the view. I'm going to set my active window back to 1. And I want to show you what the apply to, why the apply to is important. And so in this case, I'm going to go ahead and go add. I'm going to add a mesh over top of my existing plot. And so this should just draw some lines. But you'll notice I have the apply operator to all plots selected. And so now you're actually seeing I have a mesh that also has an isosurface operator, which is not what we're going to want in this case. And when I click delete, since it says apply operator to all plots, it actually deleted my isosurface from Hardy Global. So leaving apply to checked can be dangerous. So now we actually need to go back and add our slice of the isosurface again. And now we can draw because we have an isosurface of the pseudo color and just the mesh. And so that mesh is hard to see. So of course you can change your options again by double clicking on the word mesh. The mesh will open up. You can change the background, but in this case, we'll just go ahead and change the opacity down to around 25% and click dismiss. And so now we can see what the exterior of our mesh looks like around our data, and we can see through it as well. And so now we have two different plots in the pipeline browser. Apply to can also be set to all windows. And so that's really useful if you're doing some comparative analysis or something. So there's a lot of different ways that apply to can be helpful, but it also can be a hindrance if you have it set up incorrectly. All right, and so we've learned how to open files, look at file types, view file info, learned how to navigate around our views. We've seen multiple views, the window tool operators. We've seen how to add plots and operators. We've also seen how to access the attributes of our plots and our operator attributes. We've learned how to link views and how to selectively apply operators. And so that will conclude our VisIt GUI tour. And so next up, we will move on to a hands-on session. All right, now let's move on to our hands-on session number 1. And so in this session, we're going to do a little bit of basic plotting. We're going to learn how to do slices, as well as some of the options that we have with volume rendering. So you can go ahead and get your VisIt started up if you want to follow along, and we will get going. So for this session, we're going to use a skull data set. And so this is an image stack. So it's a pretty interesting data set. And in these two images that we have here, I've done a little bit of contouring of the teeth to try and pull the teeth out, as well as of volume rendering on the right, showing the bone structure. And so this is in a VTI format, which is the VTK image data format. All right, so now we'll head over to VisIt and take a look at our skull data. So I already have it open. I'm going to close that real quick. So we'll go to open, click on skull.vti. VisIt knows how to open these, so just click open and we've got it loaded. And so as I said, I initially like to just generally do a pseudo color to see if I can see anything. So I'll go to add pseudo color of image file. That's the only variable we have that's available to pseudo color. And I'll click draw. And so now you can't see much. We're just seeing the outside of our bounding box of our data. We can't really see much that looks like a skull yet. So let's go ahead and dig into this data a little bit. So let's go ahead and slice it, and that'll let us see inside of the data. So we'll go ahead and go to add operators, slicing, and let's just do a regular slice. And then double click on your slice operator to pull up its attributes. And let's go ahead and uncheck project to 2D, and that'll let us view this slice in 3D. And then we'll click apply. And in this case, I know that I want to look along the Z-axis. So I'm going to also click the Z-axis, click apply, and then click draw. And so now we can see that my slice plane is set up at the bottom of my Z-axis in 3D here. And we can actually interactively change this now by going up to our toolbar and clicking on the plane tool. And so this is nice. It allows us to move our plane interactively. So I want to move it up somewhere around the middle and see what we can start to see. And now we can see there's a little bit of the teeth there. There we go. Go down a little bit more. We're starting to pull out the teeth. We can see the back of the jaw. So we're getting a little bit more information now. And so something else we'd like to go ahead and do, I'm going to go ahead and do add another pseudo color of image file. And in this case, I'm going to go ahead and add another slice. And I want to go ahead and just add another regular slice, double click on it, and we'll let it be along the x-axis or the y-axis in this case. Don't project it to 2D, click apply and click draw. And so now we've got a second slice that's being drawn, and we'll go ahead and move it to the middle. Oops. And if I change my orientation, there we go. Now we can kind of see what the middle of the skull looks like here. And so you can see now that the slice operator is pretty useful for just getting into the middle of the data and seeing what things look like. So I'm going to go ahead and delete these now. And let's go ahead and add a contour plot just to see what a contour looks like. So go to add contour, and this will add just 10 different contours. So that's fine for now. We'll just see what that looks like. Click draw. And this will take a second. So it's taking 10 different values out of the data set and rendering those values as solid. And so you can see already, it actually kind of pulled out some of the information for us. We can start to see the teeth and the jaw back here. So that's kind of cool. So a contour might be a good way to view some of the structure. So why don't we go ahead and change this to values now? Let's go ahead and check out, say, value 50. So change select by to values, write 50, click apply. There we go. And so now we can kind of see a bit of the skull, a lot more of the skull. In fact, we still have some noisy data here at the bottom, but we can see that the value 50 is actually corresponding pretty well to some of the bone structure. And so if we want, we can actually add multiple values to add a little bit more information here. So we can say 60, 70, 80, just to see what that does for us. And that'll pull out more contours. And so you can see the higher we go, we do get a little bit of more what's probably bone structure there. So maybe we need to go down a little bit. So why don't we say, let's add a 40 and see what that looks like. So 40, yeah, see that is now on top of the red, so that it added even more bone structure, but we're getting more noise, as you can see. So the lower we go, the more noise we're getting out of this image. We can start to see the skull really well now. And so that's a bit about how just to do some basic plots and do some basic slicing. So let's go ahead and delete that. And let's go ahead and do a volume rendering. So we'll go to add volume of image file and just click draw to see what it initially looks like. So initially our transfer function is not too bad. We can see the skull, a lot of stuff's transparent, and we can see a lot of noise around the skull, but that's not too bad. And so what a transfer function is, if you haven't worked with one before, is it is the function that defines what variables are opaque and what values are opaque and what values are transparent in this image. And you can see here what this is showing us is our transfer function. So we have transparent variables down here at the blue, 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 green range, and then it starts to get more opaque as we get to red. So if we scroll around the back of the image, we can see definitely the red is actually pretty opaque in this image. So I'll click reset because we're zooming in too much. And then rotate it back. All right, and so then I'm going to go over here to my pipeline browser and double click on the word volume to bring up our volume plot attributes. And so what I'm going to go ahead and do is go to the transfer function. I'm going to start by changing the color table. Since this is an image of these are X-ray images, we can change it to an X-ray color scale. That might look kind of nice once we get our transfer function fixed. And now we can go ahead and work on our transfer function. And so what we're seeing here is our transfer function editor in VisIt. And so we're seeing a few different bits of information here. We have our color scale, which is X-ray, so it goes from white to black in this case. And then we also have our transfer function, which is this lighter white line. I'm gonna go ahead and remove that just by clicking the black. So there's no transfer function now on this data. So if I click apply, everything will be gone. Everything is going to be transparent. Now we can see a histogram too. And so this is really useful information. This shows us the value distribution of all of the values in our plot. And we can see that for most of the values, there's a ton down here at the very lower end. That's a bunch of noise. So we want to make sure we don't render that. And then we get a big spike and then it tails off again. So I'm going to go ahead and add a basic transfer function, and you do that by clicking in the window, holding your mouse down, and dragging. And so I will just do this, and now everything that's white over here will be opaque. Everything that is not white will be transparent. So I'll click apply, and we can say that's actually pulling out the skull a little bit, but we need to get a little more. We need to get some more opaque values in this case. So I'm going to turn all of this opaque, and I'm going to get a little bit of this bump in the histogram as opaque as well. And click apply and see what that looks like. All right, see, I went a little bit too far there. So now I've got a little bit of the noise showing up in my transfer function. So I'm going to reduce it a little bit, make it a little bit more transparent. Click apply, still kind of noisy. So we'll come back and do that again. Click apply. I see what's going on. So right here, we probably need to reduce this to be something closer to that. Okay, that's a little better. Do that. There we go. And so now we can kind of see the bone structure being pulled out through our volume rendering pretty well. And so again, if you don't like the X-ray colors, we can go back to something with color to pull a little bit of more information out potentially. Go back to hot desaturated. Now we've got some iridescent blue and green going on here. And if you want, you can also turn your attenuation down, which helps you see through the data a little bit more. And now there's a little less noise showing through. And we can see our skull rendering. And so that's a very basic introduction to volume rendering in VisIt, as well as some basic plots and operators. So if we want, we can take a look at another operator, which is kind of interesting. We can take a look at how to do a pseudo-color that is similar to a contour. So the contour pulled out a number of different levels from our file. So we can do a similar thing by going to pseudo-color image file and then adding another operator that's actually a selection operator in this case, called an iso volume. And so what an iso volume is this is going to take, I'll double click on the iso volume to pull up the attributes. So what this is going to do is this is going to take a lower bound and an upper bound, and it's going to make everything between that lower bound and upper bound solid. So before, when we did contours, we selected individual values, 40, 50, 60, 70, and 80. So what we can do here is we can actually say, I want to have the value 55 as my lower bound, the value as 70, say, is the upper bound, and this will make everything between that range solid versus just the individual values like a contour does. So I'll click apply and then click draw. And this will take just a second and it will pop up our data now. And so with the skull data set, it all looks pretty similar because the contours were doing fairly well pulling out the structure of the data. In some of your data sets, a contour will look vastly different than a volume will. And so in this case, we can actually see the teeth pulled out pretty well with the values that we selected. And so that's just a hint that there are a number of different ways that you can get to the similar or same answer in VisIt by using different operators and different plots in different ways. So next, we'll move on to our next hands-on session. So moving on, let's go on to our hands-on session number 2. In this session, we're going to discuss screenshots, making movies, creating animations, custom expressions, queries, as well as saving our VisIt state. So first up, we have screenshots and movies. Here we have an example of the save window options in VisIt on the left over here, as well as a animation that was saved out in VisIt on the right. So for a screenshot, they're very easy to create. All you have to do is go to File, scroll down to Save Window, and your window is saved. Before you do that, though, generally it's a good idea to set your save options. So go to File, Set Save Options, and this is where you can set your file name, your directory, your file output type, the image size, which is important. Generally set that to at least 2048 so that you get a decent resolution image. And then if you'd like to save an image with a transparent background and you're using the PNG file type, you can also set this alpha channel, which will give you a transparent background. So once those are set, hit apply and then hit save window, and you will save your screenshot. And so movies are just as simple. All you have to do is go to the save movie, and I will do a demonstration of that right now. So we'll go over to VisIt, and we will open up a file. In this case, we'll just open up noise again. Once our file is open, we'll just do a pseudo-color. So go to add pseudo-color, scroll down to whatever variable you'd like to see. I'll try radial this time. Now, if we're going to save an image, we'll make it a little bit nicer. So we'll do, let's go ahead and do a slice of an isosurface again. There, we'll get some cool radial pattern this way. Yeah, we'll look at it like that. Now, to save our image, all we have to do, we'll set our save options. I will change my directory so that it saves it somewhere I'd like to see the images. Just put them on the desktop. I'll leave it named as VisIt. VisIt will append file numbers to these, so you can just save as many as you'd like. We'll increase the resolution. And go up to 1:1 aspect ratio, click apply, dismiss that, and then we can just simply do file, save window, and you'll now see that VisIt has saved our image. So we can go over that, and there it is. To get back to our nicer background, we'll do just a couple quick changes again. I'll change the background to black. I'll go to my annotation controls, turn off the database user information as well as the 3D bounding box. So now there'll be a little less clutter. We'll go ahead and save this again. And now you'll see that VisIt just appended the number 1 to the end of this image. So it's as simple as that. Now, saving a movie is also super simple, but to do that, we're going to want to have a time varying data set. So I will go ahead and delete this data. Go ahead and close it, and we'll go ahead and open up the aneurysm data. And so we'll explain more about the aneurysm data shortly, but just go ahead and open up aneurysm.visit. All we have to do is add a pseudo-color of pressure and click draw, and we'll get our heart showing. And so now you'll see a time slider right here, and all we have to do is click play. Except the screen's going to be fun for us. So we're going to go ahead and do the following. We're going to restart VisIt. Sometimes it gets into a weird state, and this is just the quickest way to solve it. So VisIt's restarted. I'll now go reopen that aneurysm data. Add a pseudo-color of pressure, click draw. All right, so we're back to where we were. I'll change my background again so that it looks a little nicer. Okay, and so now if we click play on our time slider, what we're going to see is every individual time state played in a row. So we're going from time 0 to time 199. And you can see as we progress through time, the pressure on the exterior surface of this plot changes. Doesn't change quickly in places, and then you get to times where it changes very quickly. And so this will be perfect for saving our movie. So to save a movie, we'll just go ahead and leave it in this orientation, maybe zoom in just a little bit. And then we'll go to File, Save Movie. Save Movie Wizard will pop up. We'll just do a simple movie. An MPEG movie is just fine in this case. We'll leave the window size as our resolution. And then to add this movie to our output, click this arrow. And now you'll see that we're going to output a movie. So click Continue. We'll go ahead and increase our frames per second so it plays a little faster. And I will decrease the number of frames. I'll decrease the last frame right now just so that this goes very quickly. And so we'll go to last frame is 100, and I won't render the last 99 time states. And so then we'll say continue, change the directory to the desktop so we can play this, and continue. And you have an option now that we can use a new instance of VisIt or use the current session. We'll just use the current session since this should be fairly quick. You'll see VisIt will pop up its command line interface, and you'll see a movie progress bar start to play. And so now, while those frames, so what this is doing is it's generating individual images, and you can see down here at the bottom of the screen, it's saying it's saving the window. And so it's going through each time state, saving the window, and then at the end, it will composite these into a movie. So we'll let that run for a second, and we'll move on and check out our next slide. So after screenshots and movies, we want to go ahead and check out if PowerPoint will play. Which it won't, so we're going to have to wait a second. There we go. So after our screenshots and movies here, we're going to talk about animation and keyframing. And so if you don't know what keyframing is simply setting a view and then you set that as a keyframe. And so what that means is when you change the view to another state, it will interpolate between those two states. And I'll explain that more in a second. But that's what a keyframe is you set keyframes that you want to see, and then the animation will move the image to reach those keyframes. And so quickly here under controls, there's something called animation, and this is the place where you can actually cache your animation for faster playback, which is nice. If you're going to repeatedly play your data over and over again, you can increase and decrease your animation speed. And so those are interesting settings to play with. And then also under controls, there's something called keyframe editor, and then that's where we'll set our keyframes. And so in this case, I created a movie that starts off by doing contours, and then the contour, and then the image rotates, the contours fade away, and we end up zooming in on the image. But PowerPoint's not going to cooperate by playing this, so I'll show you how to create this right now. So now our movie is done. Actually, it's encoding. That's why we've got some slowdown in PowerPoint. Our movie's encoding. So while the movie's encoding, so it's almost done. We're on frame 166. So we'll wait just a second for this to complete. So I think now that it's encoding, we can go ahead and delete our plot. We can close this data, and we can open up the noise data again. We'll make our movie with the noise data. So go back to noise, double click. Actually, so our movie's completed. Okay. All right, so noise is open. We'll come back to that in just a second. But now let's go ahead and check out our movie. So we'll double click and open our movie. And we can see that we have our heart animated over time. So very easy to create a simple movie. And there are advanced tools to make even more advanced movies. You can have different plots overlaid on top of each other, time sliders, and more. So it can start to look very nice when you spend a little bit of time. And we'll have some scripts that I'll talk about later on that you can do this on ibex or Shaheen as well. So now that noise is open, we're going to go ahead and create some keyframes. So let's go ahead and add, and in this case, I want to create a contour plot. And we will just do a contour of our favorite variable, Hardy Global, and click draw. And so we'll see an image similar to what we saw in the movie in the PowerPoint slides. I'm going to change the contours to a color table this time, so those colors are a little bit bright. Why don't we tone them down a little bit? All right. So I will leave this open. So we'll actually want to look at those attributes in a second. So to do some keyframing, let's go to, I'm going to reset my view back to its basic settings. I'm going to go to controls. I'm going to scroll down to keyframing right here. Click keyframing. Once the keyframe editor is opened up, I'm going to expand it out because we're going to want to be able to see a wider screen. And now this is where we need to set the number of frames. And so since this is a data set that doesn't have time in it, the number of frames is a little less important, but we need to set enough frames so that we can have time to do our transitions or our keyframes. So I'll also set 50. So we'll set 50 keyframes, hit enter. And so now we can see we have 50 different states that have showed up here. And we can see that we have a view attribute and our plot is showing up as well. To enable keyframing, you have to click enable keyframing and then click apply. And so now if we come over here, you'll see that we have a time slider that's active. And what this time slider is doing is this is a time slider for the keyframe editor. And so now it's going to play through our keyframes. And nothing's going to happen because we haven't set any additional keyframes. So I like this view. And to set this view as a keyframe, you make sure you have use view keyframe selected. And then you can click add view keyframe. And you'll see that a view showed up here under the, you'll see that a bar showed up by the view as a keyframe. And so let's say you don't like this view and you want to delete it. To delete a keyframe, hover over it and right click, and that will disable that keyframe. Let's see. There we go. Maybe it won't work for the initial keyframe. So let's set another one. I'll rotate it, click add view keyframe. Then we should be able to delete that one. There we go. Doesn't work right at the beginning of our keyframe editor. So I'll reset this view again, click add keyframe, add view keyframe, it'll overwrite whatever was there. So now I will pull this bar down 10 or 15 time slices. I'll rotate it. And so then this rotation right here will be my next, and I'll also zoom in a little bit. And so this will be my next keyframe, and I will set this view keyframe. And now the interpolation I was talking about, VisIt will set up the camera, move it along a spline, and it will follow the data. And so what that will look like is if we click play here, we can watch the camera moving around the data. And we zoomed in just a little bit as well. And so the next thing that we'd like to do, let's go ahead and scroll down a little bit. Maybe let's change our number of contours. So right now we've got 10 different contours. Why don't we reduce that to 4 or something? And then we'll click apply. And you'll see that a attribute keyframe showed up on our time slider. And so if we scroll back, we'll see our original 10. And now if we play, over time, the number of contours will reduce down to the 4 that we said that we wanted. So some more stuff that we can do. Let's go ahead and add another view. why don't we zoom in a little bit? Let's see, this looks like a nice view. We'll zoom in down there. And I'll set this as another view keyframe. I'll go down a little bit further, and I will change my number of contours again, say just down to 2. Click apply. And then that actually caused the view to jump right up into our camera. So I'm actually going to back out a little bit and rotate it one last time. Set another view keyframe. And at the end, and so actually, so right here, I want to go over to my contour plot, and I want to let's see. Now that'll be fine. And so now this will be our final movie. So let's go ahead and just play this. So we start off with our original contour plot, 10 contours in our basic view. We rotate, reduce the number of contours, zoom in, zoom back out, and it's kind of a wild ride. And the reason it's a wild ride is because we only set 50 keyframes. And so the interpolation between our states is happening very quickly. So if you want a smoother movie, you use more keyframes. But I didn't do that today just because it takes a lot longer to render when we have a lot more keyframes. And so we'll quickly let that go off and render its movie. And so you can see it's just stepping through each of the time steps, or the keyframes in this case, and rendering the movie. All right, and so while that movie is rendering, let's go off and take a look at our next bit of information that we're going to look up. So the next thing we're going to look at in VisIt is the query window and the pick operators. And so the query window is where you can do a ton of different exploration of your data. You can ask information about the variables, you can ask information about the mesh, you can start to use the Python query editor. So if you have your own queries that you'd want to do, you can just simply put those in there and execute those in VisIt. And then the pick operator is something that's really valuable for debugging and even for other things. But so for what it means is you select a point on your image, and it will tell you where that point is in your data set, the values, and et cetera. So if you have some areas that look funny, you can actually click on those, figure out what they are, and then you even go back into your code then at that point and see maybe why those values don't look the way that they should. And so let's go ahead and go back to VisIt, and we will do some queries and look at some picking. So we'll get back to VisIt. So the movie is almost done, just finished. So we can go to the movie now and see what it looks like. So it'll play very quickly because we told it to, but that's a very simple movie, and that's just an easy way to create a quick, simple animation. And you can create animations that are less simple, of course, by increasing your number of keyframes. You can overlay text, you can overlay images, all sorts of things that you can do with the keyframe editor and annotations. But for now, let's go ahead and do some queries. So I will go back to our original time step here, zoom in a little bit, and then go to controls, scroll down to query, and our query window will pop up. And at the top here, we have our standard queries and our Python query editor. And so you can even load a script if you want, and you can just run that script right here in the query editor. But for today, we'll just use some standard queries to help sort these queries. Sometimes it's nice just to go in here and select what you want to learn about. So I'd like to learn a little bit more about this mesh. Maybe what's the 3D surface area? Maybe where's the centroid? And that'll give maybe the exact point of the centroid. We learn a little bit more about the grid. So this is an unstructured mesh that we have now that we've turned it into a contour plot. Let's see, we can know the number of nodes, we can know our number of zones. And you also have query parameters that you can set over here. So there's something called actual data and original data. So what actual data means in this case is it's the data that's being used to draw this contour plot. The original data comes from our original data source. And so the number of zones now in this actual data is going to be less than our original data. So if we query this, actually the number of zones is more in this unstructured data. So that actually makes sense. So our original data was not unstructured, but now that it is, we actually have more zones. So actual data versus original data. And then we can also check out our variables. We can figure out what our average value is. So the average value of Hardy Global is 3.4 joules. We can check out min and max. And that'll give us our min and max values and tell us exactly where they are. And lots of other things that we can do with the query editor. So that's just a quick overview of the query editor and what it can do. A lot of stuff you can learn there, and of course, all of this can be scripted as well. Next up, let's go ahead and do some picks. And so we don't need to go to controls for that. We can just go to our window here, and we can go to our pick modes. And so those are on this toolbar right here. We have a zone pick, a node pick, and a spreadsheet pick. And so today we're just going to use a zone. So I will pick a point on this plot and say this yellow circle and click on it, and that'll pull up the pick window. And so there's all kinds of information that we can learn about this point that we just picked now. So we can learn what the data set is, of course, the mesh, the point, its zone, and all of the different information around that point. We can also do something called a spreadsheet pick, which I'll show really quickly. And so this pulls up all kinds of information about the indices around where you just picked. And so that's something you can learn more about in the VisIt documentation if you're interested in doing a lot of debugging through the visual interface here. Okay, so I'll go ahead and delete these plots. And so now we'll go back to the slides and move on to our next and final bit of information that we're going to learn in our hands-on session number 2. So next up, we're going to learn about custom expressions, as well as how to save our state in VisIt. And so that's important if you want to get back to where you are without manually adding all of your operators back in. So we'll go back to VisIt now, and we'll open up a new data file. And so to open up this data file, this is going to be our plain text file. So this is something that we're going to have to set some open options on. So it's called pointbox.txt from our example files. And it's a plain text file, so it's CSV in this case. So we'll scroll down to plain text as our reader. Scroll down, plain text shows up. And now we need to set our default open options. And so in this case, it is 3D. So I'm going to set my coordinates here for my X, Y, and Z values. And so in this case, I know that they're in column 0 for X, column 1 for Y, column 2 for Z. And we'll go ahead and click OK and open. And so now we can go in here and we can say, what does my mesh look like? And we can see, whoops, I've got pick selected again. So I have to unselect that and go back to my edit mode. So now we can see that we have a box of tiny white points. And so to make those more obvious what they are, go ahead and just change the mesh color to something bright. And you do that by double clicking on your mesh. That'll pull up your mesh plot attributes. So now they're pink. We can make them spheres, and spheres are nice way to render points. Increase the sphere size a little bit. And turn on a little bit of smoothing. All right, so now we'll reset our view. And you can see we just have a bunch of points in 3D space. And so that's how you open a CSV file. Very easy to do once you set your options. The custom expression comes in that I'd like to display some vectors, but if I go to add, go down to vector, I see that I don't actually have any vector variables available. So I need to create one. And so to do that, I go to controls, I scroll down to expressions, and this will pop up my expression window. So to create an expression, I click new, and then I'll just call this a point vec. The type is going to be a vector mesh variable because these are vectors. And now to create a vector out of 3D points, I'll put in a opening curly bracket, and then I'll go to insert variable, scroll down to scalars, and we can see that today my variables are named var0, var1, and var2. So var0 should be x, click enter, put in a comma, go back to scalars, var1, comma, go back to scalars, var2, and our closing curly bracket. And so that should create us a vector now out of these 3D points. We can click apply. And then we'll go back to our plot window, go to the pipeline editor, click add, go down to vector, and you can see I now have a vector variable showing up called point vec. So I'll add that, just click draw, and recenter the window. And you can see now I have a vector coming off of every single point in the data set. And so that's a very simple custom expression. You can create very complicated custom expressions if you have lots of different operations you want to do. You can do all kinds of math operations and more. And so this is just a simple example to show how custom expressions can be generated and create new variables out of your existing ones. Okay. And so let's say that I love this plot and I went through a lot of work to create this, and that tomorrow I'm going to have a new data set that's the same format, but different data. And I'd like to just load it back up and view this same plot with that new data. To do that, I can easily do that by going to File, and I can save a session. And so what a session file is, it saves a VisIt session. So you can see it says .session down here, and that will let you reload all of your pipelines and everything and get you back to this exact state later on. And so session files are really nice to use. So that will conclude our hands-on session 2. So we'll move on to hands-on session 3 here in just a minute. Our final hands-on session is going to be about time-varying plots, doing more queries, and vector fields. And so we're going to be doing this on an aneurysm data set, and this comes from the VisIt website. So it's called aneurysm.visit. There's 200 different time steps. And the interesting thing about this data set is it makes use of something called the .visit file format for loading time steps. And I'll show you this here in just a second. And so here's a few different views of some of the images we'll be creating: pseudocolor plot, vector plot, and then some streamlines. So what is a .visit file? So what a .visit file is I will open it up here. It's simply a text file. And in this case, all it's doing is it's listing the individual files that make up this data set. And so in this case, they're time steps. So every time step has its own file. And so the .visit file just is a way for VisIt to know that this is a time varying data set and that it goes from time step 0 to time step 199. So we'll go to VisIt now and we'll get this opened. So we'll delete everything that I currently have, close the existing one, go to open, go back up one level, go to the aneurysm data and open aneurysm.visit. And so if you open data files for a second, you can see all of our individual time steps, and you could open those and view those individually. But we want this to be a time varying data set, so we'll just open aneurysm.visit. Once it's open, Let's go ahead and just create a basic pseudocolor plot again, and we'll do this of velocity magnitude, and then click draw. Oops, I'm still on pick mode, so that you got to watch out for that. Go up here and select your interaction mode. We'll zoom out. There we go. So there's a pseudocolor of velocity magnitude of our heart. One thing that might be interesting to do here is actually change our variable for a second to pressure, and you can change a variable of a plot by selecting it, going to variables, and then clicking on the variable you'd like to use. And then I'll reset my view. And so now this is a pressure. And so then we'll just click play to see what this data looks like. All right, that's not very nice. It keeps moving my view when I clicked play. So let's try this. Choose the center of rotation. There we go. All right. So it looks like got some issues with zooming here. So what I'm going to do is I'm going to restart VisIt. If you get into a weird state, sometimes that's just the easiest solution. And so with VisIt back up, I will open my aneurysm data set again. We'll go to add, we'll go to pseudocolor, create a pressure plot, click draw, and now click play, and see now things are staying in the proper view frame. And you can see how our pressure varies over time on the exterior surface of this heart image anyway. So I'll click stop for a second. I'm going to change up my view again to make it a little cleaner. Go to controls, go to annotation, and I can remove the database, the user information, and go to 3D and remove the show bounding box just to clean it up. All right, so now we can see what our data looks like, see it varies over time. And so let's start to explore this. So one thing that would be interesting, let's go ahead and add a slice operator to this. Let's do an isosurface just to see what happens. So that's interesting. And so then click draw. So it's kind of hard to know what's going on here because we don't have any context now that the exterior of the heart went away. So let's actually add some context back in. So go to add, go to mesh, and we'll draw the mesh. All right. And I've left the apply operator to all plots selected again. So that's bad. Uncheck, delete the isosurface on the mesh and try again. And then our mesh shows up. And so now those isosurfaces are starting to make sense. They're showing up inside the heart. So let's go ahead and change our transparency a little bit so that we can see through this mesh easier. Just have it be there to give us some context. And so instead of an ISO surface, what I want to do is create an ISO volume. I think that'll look a little better. So go to selection and ISO volume, and we'll select a min and max in a second. We first need to figure out what they should be. So if we look, we can see our minimum data value is -22. Our maximum is 644. So if we want to get the areas of high pressure, we can say max, and we can say our lower bound, let's say, is 300. And let's just see what that looks like. And then let's click play. And so over time, and we'll get that warning if a certain time step shows no data. And so you can see there's really a lot of high pressure at the bottom of our heart here. And so that might be an interesting area to do some further exploration. And we can turn off those warnings if we want, but for now, since it's already done, we won't worry about it. All right, And so next, let's just go ahead and delete this pseudo-color plot. And we're going to move on to a different plot. So we've seen a little bit of how the pressure acts through the heart. Let's see what it looks like with the vector field. So let's go to add vector, and then we'll do a vector of velocity and click draw. And so initially there won't be too many vectors in here. And the reason that is because of the basic setting in VisIt. It usually starts with 400 vectors. So instead, I like to change this to stride, and a stride of 1 is going to be overwhelming. So if we do stride of 1, that's a ton of vectors. It's kind of hard to see what's going on in there. So let's change it to a stride of 3. And what that means is it'll take every third vector and render that. And that looks a little bit better. Another thing we can do with vectors, if you want, is we can change the color value. So we can go down here and change it to something like hot desaturated again. We can also change the geometry. So if you want to save this out as a movie and have it look nice, you can create ellipsoids. Some people like these. I think they're kind of weird. So you can watch how the ellipsoids grow over the course of your data. So those are kind of interesting sometimes. But what looks a little bit better usually is leave it as an arrow plot, but you can change the body to a cylinder and change it to a high geometry quality. And so then let's go ahead and just click apply. And that looks fairly good. We could maybe increase our scale just a little bit. Maybe we'll change it to 0.3 and click apply, make the vectors a little bit bigger. And now we'll click draw, and now we can see how the velocity field changes over time. You can see here the velocity field increases, blood flow through the heart, and then as time moves on, velocity drops again. All right. And so that's a vector plot now. So the next thing that we can do is we can create some streamlines. And so to do that, let's go ahead and add again another pseudo-color plot. And we'll do that this time of velocity magnitude. Now let's go ahead and add a slice to that. And so we'll add just a regular slice, and then we'll double click on slice to bring up its attributes. Uncheck project to 2D. And this is where we need to set where the slice is going to be. So earlier, we saw a lot of really high pressure down here in the bottom of our data set. And so that's where we'd actually like to start our slice, I think. And so I know what those values are from checking this out earlier. So we will go to an arbitrary slice, and we'll do this at 3.5 space 3 space 5.5. And that'll set our slice at that point in space. And we also want to do this at an intercept of 3. And then we click apply, and then we can click draw. Velocity magnitude yielded no data. All right. So let's see why that was. Y-axis, my bad, sorry. So click y-axis, 0.333, click apply, and now we'll go back to our data set, and we'll see that it actually shows up down there at the bottom of the heart. So there it is. So now what we can do is open that slice back up again, and we can click make as default because we'll use that again. So next, let's go ahead and create a streamline. And so to do that, Okay, so we're not going to use that again. Okay. And so then to create that streamline, what we're going to do is we're going to go to add, we're going to go to pseudo color, we're going to go to operators, we're going to select integral curve and velocity. And so that will now give us a streamline. So double click on the integral curve operator and bring up the attributes. And so this is where we're going to tell it where we want the streamlines to originate from. And so today we want to go ahead and do a circle. And so this is going to be a source with multiple streamlines coming from this source. And so this is where we're going to set the origin that I was talking about earlier. 3.5 space 3 space 5.5. We're going to set our radius to 0.12. We're going to set our normal to 0, 1, 0, and our up axis to 0, 0, 1. We're going to change the sampling to the boundary. So this will do samples around the boundary of that circle. We'll do 20 different samples. Now we'll click apply. Next, go to advanced, and let's turn off all of these warnings because these can get annoying with streamlines. So uncheck everything, click apply. Then we can go next to the integration again, and we can change our maximum number of time steps, maybe down to 100 just for a minute and see what that looks like. Click apply. I'll move this over here to the edge of the screen and we'll click draw. So next, before we view it, I'm going to double click on my pseudo color plot. And this is where the geometry of the pseudo color plot becomes useful. We can change our type now of the geometry to tubes. And these look a little bit nicer when you're talking about streamlines. I generally like to have a tail on my streamlines, and we can put the head on the streamline as well. We can do some fast smoothing, make it look a little bit smoother. Click apply. And I'll just go ahead and dismiss that for now. There we go. And so now we're seeing how our streamlines are moving through our data. And so if you've never used streamlines before, what a streamline does is it is following the velocity field inside of this heart. And so it's advecting a massless particle at this one point in time. So a streamline does not care about time. And let's see. So if we go down here to the bottom, you'll see what select around the boundary means. And so you can see there's a circle, and we're selecting around the boundary of that circle. The number of steps. So if we go back here, we can change the number of steps to even fewer, say 10. And so we can see how the streamline advects over a short number of steps. And so even 100 steps was too much in this case. That's why everything was blue, because our streamlines were being colored by the advection time. So let's change this to 50 and see how far we advect at 50. So we're still advecting really fast. So I'd actually say we'll just drop this to 30. There we go. And so now we're seeing our advection over time. Okay, I'm gonna move this. We get a little bit more space on the window here. So now we've seen streamlines, but what if we care more about time? And so that's where a path line comes into play. So double click now on your integral curve operator again, and then go to the appearance tab. And this is where we can select path lines. And so then this is where VisIt will calculate our streamline over all of the time steps. And in this case, we should select mesh is static because our mesh isn't changing in this data set. Sometimes they do, but this will help our streamline apply a lot faster. So we'll click apply. Now, since we're advecting over time, we're going to want to increase the number of steps a bit because we're not going to get very far. So we'll change it to at least 100 steps and see how far we get. not quite far enough. So we'll change it to 1,000 maybe. And so you can see it's not getting very far at the end. I'll change it to 10,000. This will take a few seconds. So I don't want to go much higher than that. So there we go. And so then those are our path lines now. And you can see this is the absolute time over our data set. And so path lines are really interesting and very nice to be able to calculate. And it's very easy to do in VisIt. Okay. So let's see, what else did we need to do? Queries over time. And so that'll be the last thing we'll do in this last hands-on session. So now I'm going to go ahead and delete these integral curves, and I'm going to delete that, leave the mesh. I'm going to go to add, go to add, go to pseudocolor, go to, actually I'm going to go to add, and I'm just going to create a contour plot of pressure and click draw. So see some fancy blobs now. There we go. All right. So next, let's do a query. So we'll go up to controls, go down to query, and click query. And then before we do any queries, though, we need to go back up to control, go down to query over time options. And in this case, we're interested in time. So we want our x-axis on our query curve to be time. So I'm going to select time, click apply, dismiss. So now I'm going to go to variable related, and I want to know what the min-max value is of the original data. Oops, sorry, we can only do min or max when we're doing time. So of the original data, do a time query and do query. So that yielded no data. All right, let's try that again. There we go. So now what this is showing us is this is showing us our query over time. And so as time progresses through our data set, pressure starts off low, it spikes around a little after 0.1, comes back down, does 2 small spikes, goes low again, and then does another large spike a little after 0.8. And so query over time is very cool, because then you can see how a variable is changing over the course of your data set. Let's see, so we can go do another query. Let's say we want to see what the average value is just for fun over time. So click query. And you can see VisIt's working. It shows you that down there. And so now it'll just overlay this data for us. So we've got our average value in blue and our max value in green. Let's see, and if we want, we can go ahead and just quickly do a min. And our min value is quite low down there in the light blue. And so those are queries over time. And so as you can see, there's really a lot of different stuff that you can do in VisIt. There's a lot of different plot types. There's a lot of different ways that you can query and learn about your data. So we'll go ahead and leave it there for this final hands-on session. So what I'd like to do next is do a quick wrap up, talk a little bit about scripting and ibex cluster use here at KAUST. So first off, some best practices. So how do I use Pair Review or VisIt? So if your data is small and manageable, do your visualizations on your laptop, desktop, or even the IT remote workstations. That's going to be your best option. You're going to have a lot faster interaction. It's going to be easier to do, and you're going to be a lot happier. If your data is medium or large, this is where you need to start thinking about using interactive visualization on ibex. And so this is where you're going to run on your local machine, VisIt, and then connect to ibex, where it's going to load and process and visualize your data. And so there are two links here, one for peer review, one for VisIt, of some instructions that I've generated on how to do this. So you can go to those links and you can learn how to get set up to run on ibex. Next, if your data is large or huge, then you need to start thinking about doing batch visualization on Shaheen. So Shaheen does not allow currently the interactive visualization that ibex does, but you can launch a batch visualization. So that's really useful. Once you get a workflow set up, you can just launch that batch off and let it run. And finally, just a note, if you have repeatable, repetitive tasks, do scripted or batch visualization. It's going to save you a lot of time. So if you're generating files and you always want to generate a specific image, just create a little script to do that for you automatically. It'll save you a lot of time and you can move on to the more important analysis tasks. So next, let's look at some scripting examples, and then we will go look at how to connect to ibex. So we have a repo set up of peer review and VisIt script examples and how to run them both on ibex and Shaheen. So what we're seeing here is a very basic VisIt script and then its associated output. So we did a little bit of this earlier. We opened the dataset noise.silo, we created a pseudo color plot, we drew that plot, and then we did some queries. So in this case, we're doing a number of different queries. We're asking the 3D surface area, the average value, what the centroid is, some information about the grid, etc. And then you can see it's printing out down here at the bottom. We'll turn on our laser pointer. And so these are all these commands. I figured those out just by going to the command window in VisIt and recording my interactions. And then you just put them into your script and you're good to go. So how do you run these? So for VisIt, you just do VisIt -- no win. And what that does is tells VisIt not to launch its windows. -CLI, which is its command line interface. -S, which is saying I'm going to pass you a script file. And then this is a stats.py is the name of this file. Over here on the right is an example of a simple movie script that is in the repo as well. This is done in peer review, but similar one for VisIt. And so it's just taking a data set and rotating the camera around the data set. And so if you want to see how to do those and how to do those on ibex or Shaheen, you can check out our repos. So it's on GitLab, KAUST visualization vignettes. All right, so before we get to the very end, let's take a look at connecting to ibex. And so how we do that, like I said earlier, is very easy. So if you have VisIt 3.3.0 or higher, the KAUST network has already been added in, and so that makes it even easier. All you have to do initially, if you've never done this before, is go to Host Profiles and Configuration Setup, and it'll pop up this window with a number of different sites. You can see KAUST is right here. And so I've added KAUST to the host profiles. So click it, click install. It'll tell you to restart VisIt. And then you can easily connect directly to ibex. So once you restart though, go to your host profiles now from options and click on that. And you'll see that you have KAUST ibex show up. Here's all the information on how it connects. The one important thing you'll need to do is change the username to your actual username and then click apply. And then we should be able to directly connect. To connect, you go to open and we go back to this host option that we talked about earlier. We don't want to connect to localhost now. We want to connect to KAUST ibex. And so what we're seeing here is you are seeing my home directory. So we'll go to downloads. I don't have a lot of data in here, but we have noise.silo. ready to go. And then once you click on a file you want to open, now VisIt wants to launch its engine. And so this is where it wants to do some work. And so on ibex, this will launch a batch job. And so we don't need a lot of processors for this. I'll just run 2 processes on one node for 1 hour. And we'll click OK. Once you click OK, VisIt is going to launch a batch job on ibex. And depending on how busy ibex is, this could launch almost immediately, like ours just did, or it could take several minutes to connect. But once you're connected, you can know you're connected by checking out your engine. And so to do that, I always leave it down here in my notepad area. But if you don't have it in your notepad area, you go to File, go to Compute Engines, and it'll open the Compute Engines, and you can see which engines are running. And so if we see we have our compute engine running on ibex, we have 1 node, 2 processes, and so that's good to go. So it'll work just like it does on your local computer. You can go to Add any of your plots. We'll go to pseudocolor hardy global, click Draw, and it drew almost instantly. So very quick. And in this case, VisIt is actually sending us the data from ibex to our local machine, and then our local machine is rendering this image. We know that because the interaction is so smooth. And it does that because the data is so small. When you have larger data, it'll actually send you just the images. And what that's going to look like, and we can simulate that, is by going to Options, Rendering, and we go to the Advanced tab and turn on Scalable Rendering and set it to Always. And what this does is it means that the image is rendered on ibex and you get the image back and not the data. So click Apply, and you can see it's rendering, and it looks exactly the same. However, now when you interact with it, it's going to cause your image to disappear. So if I click on it and drag it, I no longer have my data set. And the reason is because I don't have these views saved locally. I only have that image that I got sent from ibex. So I need to rotate it to where I want it to be, let go. The image will be computed on ibex and sent to me, and then it displays. And so that makes your interaction a little bit slower, but it's way faster than sending huge amounts of data over the network. And so that's how we work on ibex with VisIt. So let's see. So as the final wrap up, if you have any questions about VisIt or projects you'd like to work on here at KAUST, please get in contact with me or the others at the VIS Lab. And I appreciate you watching this video. Thank you.